In this video, let's review some ACL considerations to keep in mind when we're doing our configuration or when we're doing our troubleshooting. And then after going through these considerations, I want to challenge you with a few ACL troubleshooting scenarios, and I think you'll really enjoy that. But first, let's remind ourselves about some of these characteristics of ACLs. When we're applying an ACL, we need to determine what would be the best fit here. Am I only concerned with the source and the entire IP protocol suite? If so, a simpler ACL might be a standard ACL. But if I need to specify source and destination information, or if I need to be protocol specific, not just all IP traffic, but maybe all TCP traffic, or TCP traffic on a particular port, that kind of granularity is going to require us to use an extended ACL. Also, when it comes time to apply these ACLs, we need to clearly visualize the direction that our packets are going into or coming out of a router. Imagine the packet flow going from the source to the destination, and as we're going into the router, would it make sense to apply that ACL on that ingress interface? Or would it make more sense to apply the ACL on the egress interface? And we know that an access control list is a list of access control entries, or ACEs. And we want to, in general, put more specific ACEs toward the top. For example, maybe I want to deny traffic from an entire network going to a destination, but I want to make an exception and allow specific hosts in that network. Well, if I deny the entire network first before giving the permit statements to permit the individual hosts, that's not going to work, because those hosts, they're going to be denied as soon as we hit that statement that says deny the entire network. We'll never evaluate those exceptions that say permit these hosts. So let's put the host permit statements above the network deny statement. That's an example of putting more specific ACEs toward the top. And even though we don't configure it, there is that implicit deny any at the bottom of our list, which means if I don't explicitly permit a packet, it will be implicitly denied. And when we're working with standard ACLs, the best practice is to place those as close to the destination as possible. The logic behind that is, since we're only looking at source IP address information, if we apply it too early in the packet's travel, we might inadvertently deny that packet from reaching destinations that it should reach. So to better prevent that premature discard of traffic, let's put those standard ACLs as close to the destination as possible. Conversely, let's place extended ACLs as close to the source as possible. And here the logic is, since I don't have to be concerned about prematurely dropping traffic, if I am going to drop a packet, let's drop it early on so we're not consuming network resources as that packet travels across the network only to be eventually dropped. And even though our primary focus in discussing ACLs was security-based, we were talking about permitting or denying traffic, in addition to that traffic filtering function of ACLs, ACLs can also be used to match traffic. We might see that, for example, in a quality of service configuration as we're using an ACL to classify traffic. Or we might see it in a network address translation configuration as we're matching all of our inside local addresses. And now that we've reviewed some of these considerations, I want to challenge you with 4 ACL troubleshooting scenarios. Here's the first one. Given this topology on screen, and given the configuration for R1 that you see on screen, here's the goal we have. We want to prevent traffic from PCA from reaching that network on which the servers live, 192.168.1.0/24. However, the symptom is, even though we're just trying to prevent PCA from getting to that network, we're also preventing PCB. And if you look at our configuration, at no point did I say I want to deny PCB, so your challenge is to take a look at this topology and the configuration and determine why PCB's packets are being dropped. You might want to pause the video as you troubleshoot this, then resume the video and we'll go through a solution. All right, did you spot the issue? Yeah, the issue was that implicit deny any at the very bottom of our list. As we said a moment ago, if we don't explicitly permit something, it will be implicitly denied. And that's what's happening to PCB, which brings us into our next troubleshooting challenge. We've got the same topology, the same goal, and the same symptom. And in the configuration, you can see that I learned my lesson from our first issue, and I realized, oh yes, I need to permit PCB. So take a look at that second line. I'm saying I want to permit host 10.1.1.102. That's PCB. I'm saying I want to explicitly permit it. but it's still not able to reach that network on which the servers reside. Again, you might want to pause the video and then resume the video once you have your solution. All right, in this case, even though we gave an ACE to explicitly permit that host, it was never evaluated because we did not put that more specific ACE at the top of our list. We instead began by denying the entire 10.1.1.0/24 network, which includes PCB. So it was denied in that first ACE before we ever got to the second ACE that said we should permit PCB. The fix for this is to reverse those first two ACEs. Let's permit the host first, then we can deny the network. Or we could just permit host B and let the implicit deny any take care of dropping traffic from PCA. Either one of those solutions would work for this standard ACL. Now let's troubleshoot an extended ACL. Here, PCA should be able to contact server 1 using TFTP, and PCB, it should be able to contact server 2 using FTP. However, even though PCB is able to contact server 2 using FTP, PCA is unable to reach server 1 via TFTP. Now, I'll invite you to pause the video, carefully look through this configuration, and hypothesize what you think might be going on here. All right, this was a tricky one because TFTP really does use port 69, and we can enter 69 as that port number. And we can specify FTP by giving the protocol name. We don't have to specify the port because ACLs, they accept a wide range of well-known protocol names. The issue here was with TFTP. Notice the protocol we said we're permitting in that first ACE. We're saying permit TCP port 69. However, TFTP uses UDP, not TCP. So the fix for this is to change that protocol parameter in that first ACE from TCP to UDP. And I've got one more challenge for you. In this scenario, we want PCA to reach both servers, and we want to prevent PCB from reaching either of those servers. However, our symptom is neither PC can reach either server. You see the syntax on screen, and I'll invite you to pause the video, look through the syntax, and examine the topology, and see if you can determine why we're blocking traffic for both PCs. All right, how did you do on this one? Let's go through it line by line. First, we're saying access list 150 permit IP host. So we're permitting all IP traffic for the host of 10.1.1.101, that's PCA, going to a destination of 192.168.1.0 with a wildcard mask of 0.0.0.255. So that's the network on the right-hand side of the screen. That looks perfect. That should allow PCA to reach those servers. And we have a second ACE that is explicitly denying PCB. But really, we could have omitted that because that implicit deny any at the bottom of this extended ACL, that would have blocked PCB. But the challenge is, both PCs are being blocked, even though that first ACE said we wanted to permit PCA. The issue here is we're applying the access list as it goes in to gig 0/2. And if we think about our packet flow from the PCs to the servers, any packets that would match these ACEs would be traveling left to right on screen, where a source is a PC and a destination is a server. As we're going left to right, those packets we're trying to match would never be coming in to gig 0/2. They would be going out of gig 0/2. So a fix for this would be to apply the ACL in the outbound direction on that interface. Or we could apply the ACL to gig 0/1 and apply that in the inbound direction. And I would say that approach is a little bit better because we would be following the best practice of placing an extended ACL as close to the source as possible. And that's a review of some considerations to keep in mind as we're configuring and troubleshooting our access control lists.